Chapter 3 Matter and Energy. Every day we see a variety of materials with many different shapes and forms. To a scientist, all of this material is matter. Matter is everywhere around us. The orange juice we had for breakfast, the water we put in the coffee maker, the plastic bag which holds our sandwich, our toothbrush and toothpaste, the oxygen we inhale, and the carbon dioxide we exhale. When we look around, we see that matter takes the form of a physical form of solid, liquid, or a gas. Water is a familiar example that we routinely observe in all three states. In the solid state, water can be an ice cube or a snowflake. It's liquid when it comes out of the faucet or fills a pool. Water is a gas or a vapor when it evaporates from wet clothes or boils in a pan. In these examples, water changes state by losing or gaining energy. For example, energy is needed to melt ice cubes and boil water in a tea kettle. Conversely, energy is removed to freeze water in an ice tray or condense water vapor into liquid droplets. Almost everything we do involves energy. When we use energy, when we heat water, cook food, or turn on the lights, walk, study, or use a washing machine, or drive our cars. Of course, the energy has to come from something. In our bodies, the food we eat provides us with energy. Energy from burning fossil fuels or the sun is used to heat the home or water for a pool. Section 3.1 Classification of Matter. Matter is anything that has mass and occupies space. Matter makes up all things we use, such as water, wood, plates, plastic bags, clothes, and shoes. The different types of matter are classified by their composition. Pure substances, elements and compounds. A pure substance is matter that has a fixed or constant composition. There are two kinds of pure substances, elements and compounds. An element, the simplest type of pure substance, is composed of only one type of material, such as silver, iron, or aluminum. Every element is composed of atoms, which are extremely tiny particles that make up each type of matter. Silver is composed of silver atoms, iron of iron atoms, and aluminum of aluminum atoms. A full list of elements is found in the periodic table in the inside cover. A compound is also a pure substance, but it contains two or more elements chemically combined in the same proportion. In compounds, the atoms are held together by attraction called bonds, which form small groups of atoms called molecules. For example, a molecule of the compound water has two hydrogen atoms for every oxygen atom and is represented by the formula H2O. This means that water is found anywhere, always has the same composition of H2O. Another compound that consists of a combination of hydrogen and oxygen is hydrogen peroxide. However, it contains two hydrogen atoms for every two oxygen atoms and is represented by the formula H2O2. Thus, water and hydrogen peroxide are different compounds that have different properties. Pure substances that are compounds can be broken down easily by chemical processes into their elements. They cannot be broken down through physical methods such as boiling or sifting. For example, the compound of an ordinary table salt is chemically broken down into elements sodium and chlorine in figure 3.1. Elements cannot be broken down further. Mixtures. In a mixture, two or more different substances are physically mixed, but not chemically combined. Much of the matter in our everyday life consists of mixtures. The air we breathe is a mixture of mostly oxygen and nitrogen gases. The steel in the building and the railroad tracks is a mixture of iron, nickel, carbon, and chromium. The brass in the doorknobs and the fixtures are mixtures of zinc and copper. Different types of brass have different properties, depending on the ratios of copper to zinc. Tea, coffee, and ocean water are mixtures too. Unlike compounds, the proportions of the substances of a mixture are consistent but can vary. For example, two sugar-water mixtures may look the same, but one with a higher ratio of sugar to water would taste sweeter. Physical processes can be used to separate mixtures because there's two chemical interactions between the components. For example, different coins, such as nickels, dimes, and quarters, can be separated by size. Iron particles can be mixed with sand and picked up with a magnet, and water is separated from cooked spaghetti by using a strainer. Types of mixtures. Mixtures are classified further. In a homogeneous mixture, also called a solution, the composition of the substances in the mixture is uniform. Examples of familiar homogeneous mixtures are the air, which contains oxygen and nitrogen gases, the seawater, a solution of salt and water. In a heterogeneous mixture, the components are visible and do not have uniform composition throughout the sample. For example, a mixture of oil and water is heterogeneous because the oil floats on the surface of the water. Other examples of heterogeneous mixtures are cookies with raisins and pulp and orange juice. In chemistry laboratory, mixtures are separated by various methods. Solids are separated from liquids by filtration, which involves pouring a mixture through filter paper set in a funnel. In chromatography, different components of liquid mixture separate as they are move at different rates up the surface of a piece of paper.